Hello? Yeah. Hello, everyone. Assalamu alaikum. Today, I want to talk about how AI is fundamentally changing the way enterprise data platforms are designed and operated, not through new tools, but through deeper architectural shifts. AI is often treated as just another workload, which is, the assumption is already wrong. So what makes AI workloads different? Traditional analytics is human-driven and it is intermittent. So queries start, finish, and stop. However, the AI workloads are machine-driven, so it is continuous. The models train, run, and adapt all the time. So the change from bursty to continuous computation breaks many assumptions behind the today's data platforms. Well, once computation becomes continuous, the data movement increases as well, and cost models change dramatically. So today's public cloud cost models works well for BI workloads, but once the data movement becomes a matter, becomes expensive and slow. So what worked well for analytics starts to crack under AI scale. So as a result, we see some infrastructure decision change. Public clouds are still extremely important. So, but it's no longer the default answer for every workload. So as AI moves into the production, cost predictability, regulatory constraints, and data gravity starts matter much more than before. So enterprises realize that some workloads run better or more economically outside of a single single cloud environment. That's why we are seeing a shift toward private clouds, on-prem environments, or hybrid setups. But this should not be considered as a rollback of a public cloud strategy, but it is deliberate expansion of the options. So today, most large organizations operate across more than one environment, and that is increasing. So from architecture point of view, we are moving away from monolithic systems, which tightly binds compute engines with the storage. Instead, we are moving toward to the decoupled storage where the compute engines and storage are decoupled from each other. So that creates new room for how data platforms evolve by time. But having decoupled architecture, compute and storage decoupled architecture, does not provide enough flexibility alone. So we need to standardize the data layer as well. So that's when open data formats come into the play. So with open data formats, the open data formats are not binded to any query engine or any vendor or any execution model. So organizations can evolve their platforms, depending on the use cases, business requirements. They can change, evolve, upgrade query engines or vendors without having a vendor lock-in, without moving the data or replatforming efforts. That's actually how enterprises buy the flexibility over the next decade. So alongside the architectural shifts, there is an operational shift taking place as well. As AI moves into the production, enterprises are rethinking how the platforms should be deployed and operated. Rather than relying on single vendor-managed environments, organizations are deliberately taking more ownership. That more ownership brings more responsibility to the teams, but it comes with increased amount of leverage. So teams has gained more control over the cost structure, as well as tighter alignment with the business requirements, regulatory compliances, and so on. So the current reality creates new questions for technology leaders. So some of the examples are, so can we move the AI workloads without moving the data? Or do we truly control cost at AI scale? Are we locked into a single execution model or single environment or a single vendor? These are the important questions to focus on. So what's important to highlight is that shifts are not theoretical. They are emerging from the real enterprise experiences as AI moves beyond experimentation. We consistently see that AI success quickly stress test current data platforms. Architectures that worked well for analytics start to crack under AI scale. As a result, many cloud strategies being softened. But it's not a rejection of the public clouds, but an adjustment based on the cost, regulations, and operational reality. So basically, over time, open, modular, pluggable architectures hold up better in the long run. They give organizations room to adapt as requirements evolve, rather than locking into a single vendor, single architecture, or single path. So the change is happening. Some companies, some organizations moving faster, some slower, but the direction is consistent. So data platforms evolving toward being open by design. Data stored in formats that are not tied to a single query engine, single vendor. Yeah, portability is another aspect of this structural change. So portability is becoming the default expectation. Enterprises want to ability to move the workloads, no matter if the workload is the analytics, AI, BI, ML, to the environment without having to move or rewrite the data. So wherever business requirements requires, yeah. At the same time, platforms are increasingly expected to run everywhere. So platforms are not binded into a single environment. So the environments are expected to be flexible enough to be run in public cloud, private environment, hybrid, on-prem setups. Yeah. The reason behind is the architectural freedom, designing once and retaining the ability to deploy wherever the business requirements coming. So the key takeaway is simple. AI does not require a tool upgrade. It forces a strategic rethink. Architecture becoming a critical strategy. Infrastructure is not only a technical decision, it is a business decision as well. And in the AI era, control and flexibility wins. I think it should be my last slide. Yeah. So thank you for listening. We have a desk over there. Feel free to drop by, have a quick chat. Thank you for listening.